Hello, wonderful gardeners at the Humus Heritage community. Welcome back to our channel where we celebrate the soil-building secrets that transform ordinary gardens into thriving ecosystems. Today, I'm excited to share one of the most underutilized composting treasures hiding right in your landscape, the incredible potential of fallen flowers. Whether you're tending to a small backyard plot or managing a larger growing space, this guide will show you how to convert those faded blooms into liquid gold for your soil and plants. Here's a question that stops many gardeners in their tracks. Inuskopi and dotspori. Is your compost pile lacking that extra oomph? Are you creating dark, rich soil, yet somehow your plants still seem to crave something more? The solution might be blooming right in front of you, literally. Most gardeners treat fallen flowers as garden waste, sweeping them into the compost bin without a second thought. But here's the truth that changes everything. Faded blooms aren't just pretty debris, they're secret weapons for building a phosphorus-rich soil amendment that will transform how your plants grow. In this guide, we'll reveal how to harness the hidden potential of flowers through fermentation, turning ordinary compost into an exceptional plant-feeding powerhouse. It's quite fascinating, really. There's a persistent myth in gardening circles that flowers contribute little nutritional value to compost, that they're merely decorative additions, but, honestly, nothing could be further from the truth. Flowers, especially those in their reproductive stage, contain concentrated nutrient profiles that far exceed many traditional compost materials. When a flower transitions from vibrant blooms to faded petals, it's packed with phosphorus and other trace minerals that plants desperately need for robust flowering and fruit production. Isn't that just amazing? So, the magic really happens when you start to understand the chemistry of composting at a deeper level. Flowers, they contain complex carbohydrates, proteins, and all sorts of organic compounds that, when properly fermented, actually break down into readily available plant nutrients. Unlike conventional composting, which requires months of slow decomposition, fermentation really accelerates nutrient extraction and transformation. This means the phosphorus that's locked within flower tissues becomes immediately accessible to your plants, delivering faster results than traditional methods. The fermentation process creates an environment where beneficial microorganisms can truly thrive, transforming dead plant material into a living, breathing soil amendment that feeds both your plants and your soil biology at the same time. When you incorporate flowers into your composting system through fermentation, you're not just adding nutrients. You're actually creating a micro-ecosystem of beneficial activity. Flowers contribute unique compounds that suppress plant diseases and deter pests directly within the fermentation container. Certain floral varieties possess antifungal and antimicrobial properties that protect your developing liquid amendment from contamination, while simultaneously enriching it with protective compounds that carry through to your soil. The texture and composition of flower petals and leaves create an ideal carbon-to-nitrogen balance when combined with the right base materials. Unlike tough woody materials that take months to break down, flowers are tender, easily digestible plant matter that microorganisms attack with enthusiasm. This, accelerates decomposition and promotes a richer, more diverse microbial community within your compost pile or fermentation container. The result is a more complex, stable humus that maintains nutrients longer in your soil, reducing leaching and, improving plant nutrient uptake efficiency. Not all flowers are created equal when it comes to composting value. Understanding which varieties offer the greatest benefits helps you make strategic choices about what to harvest and preserve. Marigolds stand at the top of our flower superstar list. These resilient blooms are nutritional powerhouses containing compounds that suppress harmful nematodes in soil while simultaneously offering rich nitrogen and micronutrient content. When fermented, marigolds create a liquid amendment that doubles as both a fertilizer and a natural pest deterrent. Calendula, often called pot marigold, brings antifungal superpowers to your fermentation project. These cheerful orange blooms contain unique compounds that prevent mold colonization during fermentation while simultaneously building disease resistance into your finished amendment. Nasturtiums are the quick-change artists of floral composting. Their soft, tender tissue breaks down rapidly during fermentation, and their peppery compounds act as natural insect deterrents. Nasturtiums contain sulfur compounds that many pests find objectionable, meaning your fermented liquid carries this pest-suppressing benefit directly to your garden when applied. Sunflowers deserve recognition for their architectural and nutritional contributions. While the flower heads are beautiful, the stalks and leaves are where the real composting treasure lies. Cosmos round out our top 5 with their delicate beauty and impressive decomposition rate. Successful flower fermentation begins with proper harvesting and preparation. Collect fallen or faded flowers in the early morning when their water and nutrient content peaks. Avoid harvesting during or immediately after heavy rain, as excess moisture dilutes the nutrient concentration. Here's something crucial many gardeners miss: resist the urge to wash your flower material. The surface microorganisms on those petals and leaves are essential for fermentation. They're not contaminants, they're the workforce that transforms your raw materials into nutrient-rich liquid gold. Alright, first, chop your collected flowers into small pieces to maximize the surface area available for microbial action and nutrient extraction. Then, go ahead and weigh your chopped material, since this measurement really guides your next crucial step. Now mix your flowers with brown sugar or molasses at a ratio of about 1 part sugar to 3 parts flour material by weight for drier materials. Or if your flowers are particularly moist, use 1 part sugar to 1 part flour material. Next, pack your flour and sugar mixture into a non-metal, glass, or food-grade container, filling it no more than 2/3 full. This space is important because it allows for gas expansion and air circulation. Then, cover the container with a breathable material like cloth or a paper towel secured with a rubber band. This lets carbon dioxide escape while keeping dust and contaminants out. Now, place your container in a cool, dark, well-ventilated location. Within a few days, you'll notice bubble formation and detect a pleasantly tangy, slightly fermented aroma. This means successful microbial colonization is happening. Typically, this fermentation process completes within 7 to 21 days, depending on the temperature and the variety of flowers you're using. When the fermentation completes, indicated by settled liquid at the bottom with floating debris on top, carefully strain the liquid through cloth or fine mesh. This liquid is your precious concentrate. Store it in a labeled airtight bottle in a cool, dark location. Dilute your concentrate at a ratio of 1 to 500 to 1 to 1000, so that's roughly 1 to 2 tablespoons per 4 gallons of water. This diluted solution becomes your plant superfood. Plants receiving fermented flower applications display noticeably deeper green coloration within weeks, indicating improved nutrient uptake and chlorophyll production. Flowering plants produce more abundant blooms with richer pigmentation. Vegetable gardens show increased yields and improved disease resistance. This method costs essentially nothing. It transforms materials you'd otherwise discard into a premium plant amendment. It requires no synthetic inputs, no complex chemistry, and no commercial fertilizer purchases. Instead, it harnesses the biological processes occurring in your garden every single day, accelerating and concentrating nature's own nutrient transformation machinery. Your plants receive nutrients in a form they can immediately absorb, supported by beneficial microorganisms that build soil health for years to come. Every garden is unique, and fermented flower amendments offer endless experimentation opportunities. Try different flower varieties and observe how each influences your plant's growth and productivity. Share your results and successes with our community. We'd love to see photos of the incredible blooms and harvests your fermented flower applications produce. If this guide has sparked your gardening enthusiasm, please subscribe to the Humus Heritage channel to stay updated on soil building techniques, composting innovations, and the science behind growing exceptional plants. Share this video with fellow gardeners who would benefit from turning their fallen flowers into this incredibly valuable soil amendment. Together, we're building healthier soils, more resilient gardens, and a deeper connection to the living processes that sustain our plants and our world.